Okay, Assalamualaikum. MEC281 students of my group. Okay, so in this video, we are going to learn about the 1.4 chapter, subchapter 1.4, mechanical properties of materials. Okay, so these subchapters are more on the theories, and I will go faster in this video. So in the end of this video, you have to do the exercises that's found in the notes, and then the answers you have to submit through our Google Classroom. Okay, so this chapter is like I said, is more on the theories, so it's better if you can read in details by your own, because if I read or explain in these slides, it maybe become very boring. Okay, so it may waste your time, so let's go faster in this subchapter. Okay, let's start with the definition of physical properties. Okay, physical properties are the characteristic response of materials to form of energy such as heat, light, electricity, and magnetism. Okay, so the physical properties of metals can be easily explained as follows. Solid at room temperature, opaque, conduct heat and electricity, reflect light when polished, expand when heated, contract when cool. It usually has a crystalline structure. Okay, so you must be familiar with the term of crystalline structure that we have already learned in the subchapter 1.3, 1.2 and 1.3. Okay, so example of physical properties here is about the aluminum oxide here. So there it has three types of properties. Okay, one is the transparent. Okay, we know what is the transparent means. And then there is translucent, separuh cahaya, semi light through. And then the opaque, or in Malay we call it gelap, legap, right? Okay, so there is no light or pass these materials of opaque properties. Okay, so let's go to the mechanical properties of metal. Okay, in mechanical properties, we are concerned about the toughness, brittleness, ductility, malleability, and corrosion resistance. So when you studied about the mechanical properties of any metals, so commonly there are 5 properties that we are focusing more. Okay, toughness, brittleness, ductility, malleability, and corrosion resistance. Okay, the definition what is toughness you can read by your own here. Okay, let's go faster. And then this is the tensile test. So I think that you already familiar with the term of tensiles. Okay, this tensile is focused in the subject of strength, right? Strength. The other subject. So let's go through the tensile test. Okay, tensile stress and strain. So this is already learned in the other subject of strength. So I think you know more about the tensile and stress, how to calculate the stress, and so on. So in basic, the formula for the stress is equal to force over area. So like this lah. Okay, and then this is about the stress and strain diagram. So from there we are going to have what we call elastic region and plastic region. Okay, so what is elastic region. Elastic region is the material return to its original shape after the material is unloaded like a rubber band. Okay. How about the oh, okay, so after it pass through that region, so it will become fracture. Okay, putus dan lain-lain lah. So this is all about the stress and strain diagram. It can give you information about the elastic region, yield strength, and so on. Okay, so I think this is more on your own effort to read in details. Okay. Okay, important mechanical properties from a tensile test. We can know the Young modulus, yield strength, ultimate tensile strength, and percent elongation. Okay, so the tensile stress is very important because we can know all about this information. Okay, and the other terminologies that you have to know is dislocation. Okay, also the elastic deformation, like in this diagram, it shows that initial the atom is in the proper way of crystalline structure, and then when we put on a small load, it will become stretched, and then if you unload that mass, and it will return to initial. So that's what we have the term of elastic deformation. So back to the basic of the elastic here, we know that elastic is the material will return to its original shape after the material is unloaded. So that's why it will returns to the initial shape after you unload the mass or force. Okay, so atomic bonds are stretched but not broken. Once the force are no longer applied, the object returns to its original shape, and elastic means reversible. So it can stretch and then it can return back to its original shape. So that's what we call elastic. And then plastic deformation. Okay, difference compared to the elastic deformations here is where you put the small load, the bond stretch, and the plane shear. Okay, and then when you unload that force, the plane still shear. Okay, so it will change the formation of that material. So atomic bonds are broken and new bonds are created. Plastic means permanent. So elastic means reversible, plastic means permanent. So if I say that material is plastic, so when you put force, then the shape change, then the shape the change shape will remains, and it cannot go back to the original form. Okay, so that's the difference between plastic and elastic. Okay, permanent deformation. Okay, permanent deformation for metals is accomplished by means of a process called slip, which involves the motion of dislocation. Okay, most structures are designed to ensure that only elastic deformation results when stress is applied. Okay, a structure that has plastically deformed or experience a permanent change in shape may not be capable of functioning as intended. Okay, so that's why most of the engineering applications we try to have the materials to have the elastic deformation properties. Okay, can you imagine if we put the plastic deformation materials on the structure, on the bridge structure. So when it change form a little bit through the heating during the very hot day, and what happened, and then it can be fallen. Okay, so that's why we have to study the material properties of any metals in the engineering application. It is very essential. Okay, so this is about the tensile strength. Okay, you can see here from this graph, tensile in the steel and so on have a very higher value compared to the fiber and composite like wood. Okay, and ductility. Okay, what is the means of ductility? Ductility is a measure of the plastic deformation that has been sustained at fracture. And this is the what we call equation for the elastic value, ductility value. So you have to know the basics of what is the ductility. And then the toughness. Okay, toughness is the ability to absorb energy up to fracture. Okay, if you still confused with the definition, you can return back to the early slides here that explain the information of what is toughness, what is brittleness, ductility, and malleability. Okay, once again, let's try to define what is ductility. It is an ability to deform without breaking. So more ductile means that it can change form without breaking, without goes the permanent deformation. Okay, so from the value of ductility here, we can know what is the best materials for your engineering applications. Okay, so that is what we study about the material of material mechanical properties. Okay, it's all about the text, so that's why I mentioned earlier you have to read by your own. If I explain and just read these slides, it maybe become boring. So let's go faster. Okay, fracture mechanism of metals. Metals can be failed by brittle or ductile fracture. Okay, ductile fracture is better than brittle fracture because ductile fracture occurs over a period of time, whereas brittle fracture is fast and can occur at lower stress levels than a ductile fracture. So ductiles mean that it takes time to fail, but for the brittle it is instantaneous, very fast to fail. Okay, so this is the diagram, the difference between the ductile and brittle fracture. Okay, so it from here I can think it is logical, it takes time to break here, right? It takes very long time compared to this brittle where it just snap out, or what you call the terputus terus kat sini, sebab tu dia brittle. Okay, macam case ni lah. Okay, ni this one is for the ductile fracture and this one is the brittle fracture. Okay, you can read by your own lah. Okay, so this is the exercise. This is one of your questions or exercise that you have to write for your answer have to submit through the Google Classroom. Okay, this is one of the exercise that you have to do. Okay, please be remembered, this one you have to complete and submit via Google Classroom. Okay, so hardness of materials. Okay, hardness also your hardness test measures the resistance of a material to penetration by a sharp object. Okay, hardness, overall bulk hardness of materials measured using loads in the unit of newtons. Micro hardness of materials typically measured using loads less than 2 newtons using such test as no HK in the unit of HK. Okay, so hardness test here is a general form of the test. Okay, and then macro where you measured more than 2 newton, micro less than 2 newton. Okay, nano, the hardness measured at range of 1 to 10 nanometer length scale. So in the unit of newton, it is around 100 micronewton forces. So the test of hardness can be categorized into 3: macro, micro, and nano hardness. Okay, so hardness is a measure of materials resistance to localized plastic deformations, small dent or scratch. Quantitative hardness techniques have been developed where a small indenter is forced into the surface of materials. The depth or size of the indentation is measured and corresponds to a hardness number. The softer the material, the larger and deeper the indentation and lower hardness number. So basically, the test is where you put a very sharp, materials on the specimens, and if it have the indentation, and it becomes deeper indentation means lower hardness number. Okay, macam material tu kita test, kita letak contoh paku lah, kita tukul dengan paku. So kalau paku tu boleh masuk dalam, tu maksudnya hardness dia rendah. Kalau hardness tinggi, paku tu masuk sikit saja. Okay, tu maksudnya hardness. Okay, ni contoh dia. So kalau case macam ni, resistance to permanently indenting the surface. Sekali lagi, definition of hardness: resistant to a permanently indenting the surface. Large hardness means resistance to plastic deformation or cracking in compression. Okay, better wear properties. Apa maksud wear? Wear ni apa dalam bahasa Melayu? Jadi macam terhakis dia, makin, kalau macam besi, okey, lama-lama kita gosok dengan kertas pasir ke apa, lama-lama dia akan jadi hilang material kat atas surface. Tu kita panggil dia wear lah, lebih kurang lah. Okay, so kalau macam ni, yang mana paling tinggi hardness? Of course lah diamond. Diamond is the most hard material, natural material in the world, as we found to until now lah. Okay, so kalau plastik, okay, most plastics senang kan, mudah rosak, mudah berubah bentuk, plastic deformation. So that's why it has a very low hardness value. Okay, so ni contoh-contoh. This one are the hardness testers. You can find many hardness tests in the YouTube where it tests many materials, like ball, like any daily applications. I think they do the test to show you the hardness of that materials. You can try search in the YouTube. Okay, so there are many tests for the hardness. Okay, these are the examples. The name of the test: Brinell, Vickers, Knoop, and Rockwell. Okay, so it depends on the value of the hardness number that you want to test. Okay. So conversion of hardness scales. Okay, to make the standardized value of the hardness, ASTM, American Society of what standard materials, I think, ASTM, but this is the organization in the United States, American Society of Standards. They put into the correlations here between the hardness number in the Knoop, Brinell, Rockwell, and Morse test. So you can see here diamond. Of course, diamond is the most hardest material in the world. And then you can find that if you want to do to use the sapphire, okay, sapphire also very high, around 9, okay, 9 in the most hardness, equivalent to around 1200 in the Brinell hardness. Okay, so that's how you convert between these tests to know the value of the hardness scales. Okay. So yeah, this is our final slide for the chapter 1, subchapter 1.4, and also the final slide for our chapter 1. So let's go to the summary. Stress and strain, elastic behavior. Once again, what is the elastic? Elastic is the deformation that can be reversible, okay, can return back to the original shape. Plastic is the permanent shape, permanent deformation after it has been put of the forces on that materials. Okay, so it cannot return back to its original form, original shape. Okay, and then we have the toughness. Okay, toughness is the energy needed to break a unit volume of materials. Okay, and then ductility is the plastic strain at failure. Okay, once again, please read again, try study again, and then if you have the problems, you can ask me in the WhatsApp group. So I'm sorry again, I go faster with this subchapter because I know this subchapter is very theory oriented, and I do not want you to become bored with my videos, because this subchapter more on self-reading and self-memorizing. You have to memorize most of that definitions and informations of the mechanical properties. Okay, so thank you, and don't forget to do this exercise. I will put the post in the Google Classroom. You have to submit your answer here, this exercise. Okay, so that's all for today. Thank you. Assalamualaikum, selamat berpuasa dan salam sejahtera. Okay, bye.